Assalamualaikum warahmatullahi wabarakatuh, and good morning. Okay, today we will start with a new chapter, chapter 2, which is AC circuit. So before we continue with AC circuit, I will show you. I will revise you on complex number and sinusoidal, okay, and trigonometry identity, okay. So today we just do some revision on your previous knowledge. So we start with a complex number, okay. So you remember that a complex number has, okay, a complex number you write like this, okay, 2 plus 3i or something. But for electrical, you have to change I to j, okay, because I already assigned to current, so you have to change I to j. That's it. For complex number, you have to change it. Okay. So you know that j is just equals to square root of -1. Okay. And if you plot it, okay, you can see it here at the Cartesian plane or complex plane. So you need to remember how to do this. Okay. If 2 plus 3j, so means that you have to look at 2. Okay. Then 3, the imaginary axis is the j. Y-axis is the j. Okay. So this one is, you need to know, j is 90 degree, this point, okay, 90 degree. Okay, and negative j is negative 90 degree, which is at the below. Okay. So we continue. So you need to know how to convert, okay, complex number to the rectangular form to the polar form. This is the polar form. Okay. Okay, modulus of z. So okay. Okay, this one is the polar form. Okay. So you have two forms. Either you want to x plus jy or r and the radius. So this is how you convert the formula. Okay. If you have for example, if you have in rectangular form, okay, you want to convert it, you use this formula, okay, the lowest one. And if you have the polar form, you have to use the top formula. Okay, so you need to know this. Okay, this is basic. But also there are another option. You can use your calculator, because in your test they will not give mark if you do it manually. So you need to know how to convert this using your calculator. So how to do this? Okay. Okay, if you have the older calculator, okay, you have to go to the complex mode first. Okay. Okay, so example, you have 2 plus 3i. Okay. So how to convert this to Cartesian form? Polar form. Okay, you can see that 2, and to see the imaginary part, you just shift equals to, you get the imaginary part. You can see that there are I here. Okay. So how to convert this? Just press shift and this one plus. Okay, you will get like this. So equals to, you automatically get the R, and then the angle is 56.31. Okay. So if you look here, make sure that it is in decimal places. Okay, this one is D. So D is decimal. You can go to mode radian, but in this course we don't use radian, we use degree. So make sure that your calculator in degree mode. So how to convert that? So press mode. Okay, press until you see this and press degree. Okay, make sure your calculation is in degree. So how about the new calculator? Okay, for new calculator, so you have to press menu or setup. Okay, press 2, or you can move it to 2, then equals to, so you already mode complex, so you can see I at the top. So how to do this? 2, okay, 2 plus 3, J, so J is here, okay, equals to, okay, then to convert it, press option, okay, OPTN, okay, goes to number 2. Press down and goes number 1, okay. So you will automatically convert the answer to this form, okay. So previous form and the new form is this one, okay. So another form you can use is Euler formula, okay. But in this class, we don't use the Euler formula. It's just your knowledge, okay. It's basically almost the same. It's only you have to write it like this. Okay, R cos theta plus J sin theta. Okay. Okay, this one is the plus and minus. How to do plus and minus for complex number. Okay, and before that, you have to know what is conjugate. Okay, okay, you can see here, this is conjugate. So conjugate, basically, if you have this, okay, if you have this, you have to change it. Okay, change it to negative. So what is conjugate? Conjugate. So example, you have z equals to 3 plus 2j. Okay. So what is conjugate? So how to represent conjugate? You just put a star, okay, at the superscript. So you get 3, just copy back for real number and then convert this to negative. And if the z2, for example, equals to 3 minus j2, okay. So z to conjugate, you will get 3 plus j2, okay. That is how you conjugate the number. How about if the in this form, okay? How is the z is in the 30, for example, degree 70, this one, 70 degree. Make sure you put degree, because if you don't put this, it means that your unit is in the radian, okay? Radians, okay. So this one is in degree. So how to get this? To get the conjugate, so z conjugate also use the same representation. So 30, but instead of positive 70 degree, you put negative 70 degree. Okay, same way if the z for the z3, okay, if 40 degree negative 20. So if you do conjugate, z for conjugate equals to 40 positive 20 degree. So that is how you do conjugate. So next, we look at how to add and subtract. Okay, if you see here, okay, in rectangular form, it is easier to add and minus. Okay, so for this, if you want to add and minus, make sure you group the real and imaginary part together when you do add and minus. So I give you an example here. Okay, you have V1 equals to 3 plus J4, and V2 is 5 plus j 6. So basically, if V3 is V1 plus V2, okay, so you have to group this, the real and imaginary, together. So 3 plus 5, okay, then plus j, okay, 4 plus 6. So you will get 8 plus 10j. Okay, in test or exam, for this course, you will not get mark. No mark to if you do it manually. Okay, so it's better for you to do use your calculator, because you do it a long way and you waste your time. So it's better to utilize your time properly and use your calculator. And the weakness of using this is, for example, V1 equals to 3 plus J4 and V2 is 30, okay, minus 30, how about 50, okay, degree, negative 60. Okay, for example, in this case, you cannot just add directly. Okay, you have to convert this into a rectangular form. Okay, x plus j y. Okay, so the problem is, if you do it this manually, it takes time. So if you use calculator, it's much more faster. So also, if you don't want to do this because there is no mark, you just directly do it in your calculator. So V3, for example, equal to V1 plus V2. Okay, so just use your calculator. Okay, let me show you. So if you have this, okay, so you're already in the complex. Make sure you are in the complex, okay, complex mode. Okay, so 3 plus 4i, okay, so plus 50 shift, okay, you press shift, and okay, this one, okay, you for the angle, then 60. Okay, negative 60, negative 60. So equals to 28 plus, okay, minus 39. Okay, so the answer is 28. Don't forget the imaginary part. Okay, shift equals to, you get 30, negative 39.30. So you can see the imaginary it placed here. Okay, or if you want the answer in the polar form, just press shift. Okay, this one shift plus, okay, equals to, you get the answer 48.25, and you look at the angle shift equals to, so you get negative 54.53. So that is how you use your calculator to get the answer directly. And if you use the new calculator, okay, go to the complex mode. Okay, make sure you go to the complex mode. Okay, 3 plus 4i, okay, plus 50 shift, this is the angle, okay, shift, oh, okay, so negative 60, negative 60, also you get the same answer. Okay, this is in imaginary in this mode. Okay, if you want to change it to the point form, decimal point, just press this, okay, SB. you get the answer directly, 28 minus 39 point something, okay? So then if you want to change it, just press option, okay? Okay, move down and press 1. Okay, you get the answer in this form. Okay, 48 point something, okay, to 6. And then the angle is negative 54.53. Okay, that is how you use your calculator instead of doing manual calculation. So this one is much more preferred because you will not given mark to do manual way. Okay, except in the theory, if the question asks you to do it manually, you have to do it in manual way. Okay, so okay, this is plus. How about division and multiplication? Okay, if you do like this, okay, for this case, it is better for you to do this in the polar form. Okay, okay, I give you an example here. Okay, for example, V1 is equals to 3 plus J 3 angle of 40 degree. Okay, then V2 is 5 angle of 60 degree. So if you want V1 multiplied by V2 is basically equals to 3 multiplied by 5. Okay, and 40 plus 60 degree. Okay, so the answer is 1500 degree. This is the manual way. And for example, if you okay, V1 divided by V2 is basically 3 divided by 5. Okay, multiply angle, okay, 40 degree minus 60 degree. So that is how you do division. So 3 divided by 5, 3 over 5, angle negative 20 degree. Okay, this is the manual way. Okay. Also, they don't give mark if you do it manual way. Okay. But what happen if, for example, V4 is equals to 3 plus J4 and V5 is 6 5 plus J6. Okay, if V4 divide by V5, okay, you cannot just 3 plus J4 divide by 5 plus J6. You have to convert to this form, okay, polar form. So you have to convert this, then you can do the manual way. But this one also don't give mark, so you waste your time to convert everything. So you just have to use your calculator. Okay. So how to do use this to solve this in your calculator? Okay. So for this case also, you have to go to the complex mode. You can see the complex mode here. Okay, CMPLX. Okay. So for this case, make sure you be careful the bracket. So 3 plus 4i, okay, or 4j, then divide by 5 plus 6j. So don't forget the bracket, be careful. So equals to, you automatically get the answer. Okay, this is the real, this is the imaginary. Shift equals. Okay, if you want to get the answer in the complex polar form, okay, just press shift plus then equals to. So you get the the R, and then you shift equals, you get the angle. Okay. How about the new calculator? If you use the new calculator, okay, also make sure you in the complex mode. Okay, shift 2. Okay. For this calculator, the complex mode is shown in SI here. Okay. So don't forget bracket. Okay. Sorry. There is something wrong. Okay. Shift reset all. Make sure when you do calculation, you have to reset your calculator. Okay. Okay. Then 3 plus 4i divide by 5 plus 6i. So equals to, this is the answer. Or you want, because the answer needs to be in decimal point, press this. Okay, this is the answer. Okay, if you want to show in the polar form, press option. Okay. Okay, then goes down and goes to 1. Equals to, you get the answer. Okay, also you want to change in this form, just press this. Okay. Okay, for this case, don't forget the decimal mode. Okay, is shown in D as here. Okay, make sure it is in decimal form. Okay. Okay. So you have complete multiplication and division. Now we move on to the alternating current. Okay. So okay. Okay. Previously we learned about the constant source. Okay. Now we use a AC source. Why this is important? Because we use AC in our system actually. If you look at your plug, okay, the power source, everything is in AC. Okay, in generation, in transmission and distribution, all use AC. Okay, only in your device it use DC. Or if they also have a very if the transmission line is very long, they will use DC. Okay, from your chapter 1, the DC is not very much used in the power system. Okay, but for AC, it's all used. Okay, why AC is used? Because you can easily convert the voltage. Okay, for example, in generation, the voltage is maybe around 22 kilovolt. Okay, then when you want to transmit for far away, you have to increase the voltage. Okay, why? When you increase the voltage, okay, you reduce the current. Why we want to reduce the current in your transmission? Because the power loss. Okay, when at wire there are power loss. So P equals to I squared R. Okay, R means the resistance in the wire. In the wire, transmission wire, the resistance is it's not too high, but there is resistance. So in order to reduce the power loss, we use a lower current. That's why we increase the voltage, because to reduce the current. Okay. So make sure you know the reason why we use AC in your in the generation, transmission, and distribution. Okay. When after we transmit, we have to reduce back at the distribution, because we cannot use high voltage. Okay. So for that case, okay, for this case, you have to reduce using step down transformer. It will be, you will learn this in chapter 5. Okay. So that is how that is the important why we use AC. And DC you cannot do that. Okay, you can reduce or increase the voltage, but the complexity is very high. Okay, but if you use this one, is much more easier. So this one, okay, transmit usually 132 kV or 275 kV or 500 kV for transmission. Okay, this one usually, this one not standard, so around 10 kilovolt to 22 kilovolt. For distribution, okay, there are 33 kV or 11 kV. Okay, so it reduced back to this, and then at your home it will reduce to 415 kV for three phase, and 230 for single phase. Okay, so this is for theory. You have to know what is the theory. Okay, so you can see here the generation, then transmit, okay, to 75 kilovolt. Okay, then increase voltage, then reduce back, reduce, and goes to home. Okay, another advantage, okay, is easily handled mathematically. Okay, this one you have to remember for theoretical. Okay, this is the standard. Okay, this one is in WT is in radian. Okay, pi mean 180 degree. 2 pi is 360 degree. Okay, so usually sign. Okay, make sure you know how to draw this and the unit. Okay, this is Vm. Okay, maximum voltage or maximum current. Vm, this is Vt. Okay, make sure you know which one is capital letter and small capital letter. Okay, small letter. So this one is small letter, this one is capital letter. And this is Wt if you use radian per second. Okay, if you use time, okay, you can put like this. Okay, T over 2 and T. T means period. T over 2 is half period. So make sure you know how to differentiate this and this. Okay, this is also a theory. Okay, so if Vt, okay, make sure the small letter, and this is large letter, okay, capital letter. So Vm is the maximum amplitude here. Okay, so sine, okay, Wt. So like this. So you need to know what is this. What is W is angular frequency in radian second. W is equals to 2 pi f. Okay, Wt is argument of sinusoidal. Okay, this one is in radian, so be careful. So if you want to insert this into calculator, okay, make sure that you change this into degree. How to do this? Wt divided by pi multiplied by 180 degree. Okay. So as I mentioned before, what is period? Period is basically 2 pi divided by W. Okay, if you can see here, okay, either you can use okay, W equals to 2 pi over T, or W equals to 2 pi F. F is the frequency. Okay, frequency. This is period. Okay, if they give the period, you have to use this formula or this formula. If they give frequency, you have to use this formula. So from this, you need to know how to draw. Okay. So this one T over 2, if you use this part, okay, you need to know how to draw. Okay, if you use WT, make sure you use this unit pi, 2 pi, 3 pi, 4 pi. But for if you use T, make sure you use this approach. Okay. How about frequency? So as I mentioned before, frequency is just 1 over T, or equals to W over 2 pi. Okay. So you need to memorize this formula because there will be is not available in your formula sheet. Okay. For this course, there is no formula sheet. Okay. Next, you need to know how to differentiate between lead and lag. Okay. So what is leading or what is lagging? Okay. So if you example here V1, okay, if you can see here V1 is this one. V1 equals to Vm sine Wt. Okay. And V2 is okay plus. Okay, V2 here. V2 is Vm sine Wt plus angle. Okay, certain angle. This is the angle. So means that V2 is much more quicker than V1. Okay, V1 already goes front, but V2 is goes at the back. Okay, so what you can say that V2 is basically leading V1. Okay, you need to know how to make this sentence because it is usually a question. So V2 is much more faster. Okay, if you can see here, if it is plus, okay, it automatically, if the value of V2 is much more larger, okay, the angle is much more larger, V2 will automatically lead V1 by what degree, okay? So you need to know. Or you can write V2 is lagging, V1 is lagging V2 by the angle, okay? So you need to know how to draw. If positive means shift to the left, okay? Shift to the left, and negative means shift to the right. So you have to recall back how to draw this. Okay, let me show you. Okay, for example, if you have a question like this, V1, V1t equals to 30 sine, okay, 30 sine Wt plus 30 degree, and V2 t equals to 40 sine Wt plus minus 40 degree. Okay. So what you can see here, V1 is much more higher number than V2. So means that, okay, if you look here, this one is higher. Okay. So V1, angle of V1 is much more larger than angle of V2. So means that V1 lead V2, okay, by, so 30 minus negative 40, okay. So angle V1 minus angle V2, okay. And the answer needs to be always positive, okay. So basically V1 lead V2 by 70 degree. Or if you look another way, okay, V2 lag V1 by, okay, if this flip, okay, so negative 40 minus 30, okay, don't forget to absolute, the value always in positive, okay, so negative 40, okay, V2 lag V1 by 70 degree. So that is how you determine what is lead, what is lag. So any question? Because this one usually confused by many students. Okay. So we move on to the trigonometry identity. Okay. This case, we usually use this one and this one. Okay. Okay, we usually use this one and this one. So just I give you tip how to do this, how to memorize this. Okay. So remember the tips. Okay. You have cos and sin. Okay, this is how you remember this. Cos to sin is plus, sin to cos is minus. Okay, C to S, it increasing, right? So just plus. And S to C is reducing, so just minus. So how you want to do this? For example, you have 30 cos 30 degree. So you want to convert to sine wave, so just copy back the magnitude 30. Cos is convert to sine, then 30 degree, so C to S plus 90. So you get the answer 30 sine 120 degree. So that is how you use this. Okay, use this. Same here, if you have another example, for example, 40 sine, okay, 60 degree. So how to do this? So 40, write back the magnitude, convert to cos, okay, cos 60 degree, and you look here, change from sine to cos, so needs to be minus 90 degree. So equals to 40 cos, okay, minus 60, negative 30 degree. Okay, that is important, because you will use this a lot. For another one, this one, it rarely be used. Okay, for if plus or minus 180 degree, you just put negative. And for cos, if negative, okay, plus minus, just basically the same thing. Okay, if you have 180 degree, you just put negative for cos and sin. Okay. So I show you some example. Okay, a sinusoidal current has a maximum amplitude of 20 amperes. So this is maximum current, I am maximum. And the current passed through a complete cycle in 1 millisecond. So this is period. Okay, the magnitude of the current at 0 is 10 ampere. Means that I, okay, the current at time 0 is equals to 10. So what is frequency? So frequency is just equals to F equals to 1 over t. Okay, just 1 divided by 1 millisecond equals to so hundreds 1 kilohertz. How about angular frequency? So you remember what is angular frequency is W equals to 2 pi f. So just insert the value. Okay, you get 2000 okay, pi radian per second. Make sure the unit is correct, and sometimes you can use the all the value 6283 okay radian per second. Okay, express the expression angle in radian. Okay, what is IT and express in radian? So be careful if the question asks you in radian. Make sure you know how to convert this. So how to convert this is just, for example, if you have any angle, the angle divided by 180 degree multiplied by pi to convert into radian. So for this one, you need to know what is the phase shift. So as I mentioned before, I0 is equals to 10. Okay. Okay, wait. Okay, this one I'll show you. So here is the general form. Okay, IT equals to IM cos WT plus phase shift. Okay, the maximum is 20. Okay, I show you before. So this is here. W is you already calculate here. Then you need to find this. What is the phase shift? So just insert the value. Okay, this one is, you know that I said that this one, okay, I0 equals to 10. So just insert this into this and write this. Okay, you will get this. Okay, this one become 0 because t equals to 0. This is t. So this one is WT. So equals to 0. So goes into here. Okay, for this case, make sure that your calculator in radian mode. Okay, how to do this? Okay, okay, where is it? So if you want to change the calculator in radian mode, make sure that you go to mode, okay, until the end goes to radian. Okay, make sure in radian mode because this calculation is in radian. So you move this around, okay, you move this, you get this, and cos inverse, of course, shift cos, okay, shift cos 0.5, you automatically get the answer. Okay, 1 point, this one, okay, you will get the end answer directly. make sure you know how to manipulate the sinusoidal wave. And lastly, the RMS value. So this one we still don't learn. Okay, what is RMS value? So basically, when in sinusoidal, okay, when you want to find the RMS value, is you just the maximum value divided by, okay, if you see here, okay, this is the maximum value IM, okay, and this just divide by square root 2, and this is true for sine wave only, okay, either sine or cos, okay, you can use this. Okay, if you have rectangular waveform, you cannot use this, as long as the waveform is like this. Okay, so this is what I mentioned before, average and RMS value. Okay, this one is important because, okay, usually we use the RMS. So basically you have to remember how to convert RMS. Okay, this one. This one is very important formula. Okay, it can be either voltage or current. IRMS, we make I max divided by square root 2. So this one is just for current, voltage and current. Okay, this is the general formula. We will not use this for your case. Okay, for your course, we will not use this. And this is the average, okay, average value. How to calculate it? Okay, you use this formula. This is the general formula. And this is for sinusoidal only. For average, this is just VAVE equals to V max divided by 2. Okay. Why this value is important? Okay, sorry, this one is not equals to 2. V average equals to 0. We don't use average. Okay, why this is important? The RMS and average. Okay. So if you can see here, for example, you have a sine wave. Okay, you cannot just say that the Vmax, okay, because it is not true, because the voltage always changes. This is not an effective value. And if you use V average, so what is the average? So average is basically the area under the graph. Okay, so this is in one cycle. So if you look at the average of this, so this one is equal to this one, but opposite side. So basically the V average is equals to 0. So you cannot use this. It has no value. So that's why you have to use the RMS. So RMS, okay, you will have the value. V RMS equals to V max divided by square root 2. Okay. Okay, and if you see any value, for example, at the back of your TV, for example, at your charger, they said that, for example, the rating is 230 volt. Okay, if they write like this, means that it is in RMS. Okay, if the value is only a magnitude, always assume it is in RMS. For example, if say the current is, okay, the current for your phone charger is 0.5 ampere, means that this is in RMS and not the maximum. Okay, we will not use this in your rating or any value. Okay, we will use RMS. So be careful. Okay, another one is crest factor. Okay. Okay, this one, voltmeter and ammeter are show RMS. Okay. Okay. And lastly, the crest factor is this one. Just use the formula. Okay. Crest factor for sinusoidal is square root 2. This one usually in theory. Okay, make sure you know this. How to calculate crest factor is basically V max divided by the RMS. Okay. So we take a break for